Today's daily code problem of the day is count number of maximum bitwise OR subsets, number 2044. This problem is very cool and it shows the power of bit manipulation, so don't worry if you're new to bitwise operations. I'll break everything step by step and explain as we go along. So for this problem, we're given an integer array nums, and we want to find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. So what on earth does this mean? This simply means that we need to find how many subsets of, let's say, the number 6 we can generate with the bitwise version of a number. So for the number 3, the bitwise translation would be 011. Then we could say for the number 2, the bitwise translation would be 010. For the number 1, the bitwise translation would be 001. And for 5, the bitwise translation would be, let me double check real quick. It would be, sorry, I have it written down here somewhere. It would be 101. So 101. Using this, we're going to identify what a OR function is. So our OR function, or the standing bracket like this, is basically going to take two of these numbers and combine their bits. So if we take 3 and OR it with 5, 3 ORed with 5, we are going to take their bitwise counterparts. So 011 and 101, and we're going to combine those bits to get, ultimately, the combination of 5 and 3 is going to be 7. And that's because their bitwise OR is going to be 111. So, when we're ORing two numbers together, if it's a 0 and a 1, it's going to be a 1. We're going to turn it into a 1. If it's a 1 and a 1, we're going to turn it to a, you guessed it, 1. If it's a 0 and a 0, it will be 0. And if it's a 1 and a 0, again, it will be 1. So that's how the bitwise OR function works. It looks at this one, and it's going to compare it with this one. And because both are 1s, we're going to have a 1 there in our new outputted number. So if we look at 3's second bit is 1, 5's second bit is 0. But because 3's bit is 1, the new number is also going to be 1. So 3's third bit is 0, 5's third bit's 1. So our new number's third bit's going to be 1 as well. If we look at another example, let's say if we use 2, right? And we OR it with 3. Well, 2 has a bitwise representation of 010, and 3 has a bitwise representation of 011. So the new number is not going to be a different number. It's going to be 3 again, because the output's going to be 011. Again, that's because our third bit on top is 0, our third bit on the bottom is 0. So the new bit is again going to be 0. Our first bit's 0, first bit's 1. They combined to be a 1. So this is all that the OR function does. And we want to find what the maximum bitwise OR of the subset is. And so if we look here at example 3, the maximum OR we can get is 7. And that's if we combine 5 and 3, it gets 7. If we combine 3, 5, and 1, and here I can implement that into our previously established. So 1 is just 001. Again, 1, 1, 1, it stays 1. 0, 1, 0, because we had a 1 in there, it changes to 1. 0, 0, 1, we have a 1 in there, it changes to 1. So 7 is still the same number. 315, again, it's going to be 7. 325 is 7 because we have no new bits. 3215, no new bits, it's still 7. 25, 7, 215 is 7. So that is going to be our OR function. Moving on, how are we going to implement this? So to set up our solution, we're going to make our class solution. We'll write our method count max or subsets. And in this method, we're going to take the array of integers nums. So first thing we're going to do is find the maximum bitwise OR value that can be made. To do that, we can simply set an integer equal to our max OR value, and that will be equal to 0. And then we are going to have a for loop for each num in our array nums. We are going to go through and max OR value is going to OR equal each num. So by doing this, we are going to go through each number in our nums array and OR it to our max OR value. This is simply just taking 3, 2, 1, and 5, all ORing them together, and ultimately it will be equal to 7. Because the 7 bitwise representation is 111. So it's as simple as that. That's all this for loop is going to be doing. Sorry. We're going to be ORing everything together and get the max value, which is just going to be all of our numbers ORed together. And we can use OR is equal to. It's the same thing as like plus equals, times equals, divide equals. It's OR equals. So the result of ORing all the numbers is 7. And now we're going to calculate the total number of subsets in our array that can add up to this max OR value. To do that, we're going to identify our total subsets as an integer, which is equal to total subsets. Is going to be equal to 1. And we're going to shift it to the left of nums.length. So this function is going to be a bit mask operation. It's going to shift our 1 in our bit to the left nums.length amount of times. This is just creating a mask, and it's going to be used to identify all of our max OR values. So to generate all of the possible subsets in our array, since an array of length n has 2 to the n subsets, we can calculate this using bit manipulation. The expression 1 to the left of nums.length means we're shifting the number 1 by nums.length positions. Left shifting moves the bits to the left and effectively multiplies by 2 each shift. So 1 to length nums.length gives us the total number of possible subsets. So for example, if nums.length is 3, so we're going to move 1 to the left 3 times, it's going to be 8. Because 1 in binary is 0001. If we shift it to the left 3 times, it's then going to be equal to 1000. So it's going to shift here, and then here, and then here. So it's going to be 3 times. So we could say it's going to be 1 times 2, which is 2. 2 times 2, which is 4. 4 times 2, which is then 8. So it's as simple as that. We're then going to loop through all of our subsets using this, and we're going to represent each subset with the binary mask. So int subset with max OR is going to be equal to 0. This is going to be what we use to count. And for each integer subset mask is going to be equal to 0. Subset mask is going to stay less than our total possible subsets. And then we're going to increment subset mask by 1. So now we're going to loop through all of our subsets. We represent each of these subsets using a binary mask. And for example, if we have an array ABC, the binary number 101 means we include A and C in our subset. We leave out B. By looping from 0 to our 2 to the power of n minus 1, we'll cover every possible subset. We're then going to calculate the OR of each of these subsets. So we're going to have an integer current OR value. It's going to be equal to 0. And for int I is equal to 0 as long as I is less than nums.length I plus plus. So if our subset mask shifted to the right I times and 1 is in that position. So we're going to check if our subset mask shifted to the right I times has a 1 at that bit already, and it's equal to 1, then our current OR value will be OR equals nums of I. So this inside loop, we're going to calculate the OR value of the current subset. We use the right shift to check if the ith bit in the subset is set to 1. If it is, we include the ith element of the array in our OR calculation. So here's how it works. The subset shifted to the right of I shifts the mask to the right I positions, and the and I checks if the rightmost bit is 1. If it is, that means that the ith element is included in our current subset, and we can use the OR equals operation to combine it with our current value. Next, we are going to check for the maximum OR value. This is going to be outside of this inner loop, but still inside the other loop. So we're going to check if our current OR value is equal to our max OR value. Then we can subset with max OR, increment it by 1. So after calculating the OR value for the current subset, we compare it with the max OR value. If they're equal, we can increment our subset with max OR. Finally, we just have to return our subsets with max OR. Let me make sure I spelled that right. Subsets. Yep. So finally, we can return the count of the subsets that give us our max OR. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions. So if we quickly review what we did, we calculated the maximum possible OR value using all the numbers. So that's what we did here. We calculated the maximum possible. We then used bit manipulation to generate every possible subset. So that was this. And then for each subset, we computed its OR value and compared it with the max OR. So that's what we did in the inner loop. And if they matched, we incremented our counter, which is what we did here. So this problem is a great example of how bit manipulation can make code more efficient, and I hope it was helpful. So thank you. Follow more daily LeetCode questions, and leave me any comments asking any questions. Thank you.